Hey guys, Mr. Barnes here again, bringing you another math video on differentiation of trig functions involving two variables, x and y. Implicit differentiation, as the kids call it these days. So this is an example where you have to use the product rule in order to be able to differentiate differentiate this guy. So because we have two functions multiplied against each other, so I have x squared here and cos of y. So I'll have to use my product rule in order to do that. So if you remember the product rule, it's simply, f g prime plus g f prime. Whoops. Oh, did I frighten you guys there a little bit? Let's see if I can rearrange this guy. So just like that one. All right. So now what I want to do is I want to use that. So I'm going to call my f to be x squared. So I just write my x squared there like that. So then I have to take the derivative of g prime. So the derivative, of course, of cos is negative sine. So negative sine y. But now remember that anytime I'm differentiating with respect to y. So I have to use the chain rule. If I have anything inside the cos or a sine or tan or whatever you got, that's not x. So the derivative of y, well, I need to find that in order to multiply my function, my fu prime, by u prime. So my y is essentially my u. So my y here is just going to be, derivative of that guy is just going to be y prime. So I have to multiply by it. So always remember to do that. Something people often forget when you have a simple thing, you think, cos y, derivative of cos y is just negative sine. It's actually not just negative sine. When it's with respect to x, it's negative sine y times y prime. And then, of course, derivative of 1 with respect to x is just 0. That's what we like. And silly, of course, I forgot something. The second half of the product rule. So my g just goes. I was going to say it would have been too simple, hey? Cos y, and the derivative of x squared is just 2x. There we go. I feel like I'm learning to write again when I'm writing on the iPad. Alright, so now I need to solve this for y prime. So again, what I like to do, anything that doesn't have a multiply by y prime, bring it to the other side. So this guy right here doesn't have the multiply y prime, so let's get rid of it, bring it to the other side. So, and I'm going to rearrange this guy a little bit just to make it a little bit nicer. So that's negative x squared y prime sine of y. So that looks a little bit prettier. And it's equal to negative cos y. Actually, I'll rewrite that guy too. So negative cos x, or 2x, right, times cos of y. So if you see, I have a negative that I can cancel out here, so I can, squiggle out my negatives. And then I can cancel x here, cancel an x to squared there. So I'm just left with x y prime sine y is equal to 2 cos y. So again, now I want to get rid of anything next to my y prime, so I'm going to divide this guy by x sine of y. And then over here, x sine of y. So, got some cancellation happening. This guy's gone, this guy's gone, this guy's gone, this guy's gone. So I'm left with y prime is equal to 2 cos y all over x sine y. Now, if you wanted to make this look a little bit pretty, I guess you could rearrange this as 2 cotan y, and I ran out of space, I think, cotan y all over x. I'm going to have to fit this y in here somehow. Let me just re-erase this and make it a little bit smaller. You guys get the picture, hopefully. There we go. So 2 cotan y over x. Now, personally for myself, if I was on a test, I wouldn't really care if my students, if you guys, did that. But, it's something to think about. It certainly wouldn't hurt. If it's obvious, you could definitely do it, and then you wouldn't have to worry about it. If you're not my student, and your teacher's a real stickler for stuff like that, then you might want to consider it. Well, hopefully, this video helped you, and I'll see you guys in class.